Just hold on, just hold on. Let me check it out. Okay, can you hear me now?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Yes.
So anyways, we are talking about IGP over here. This IGP basically stands for Interior Gateway Protocol. Okay, I for interior, G for gateway, this is P for protocol. All these RIP, EIGRP, OSPF, IGRP, ISS, all these protocols, they come in IGP. Okay, why do we say IGP? Because we can use any of these protocols to perform dynamic routing within an organization, within a company. Okay, so all these like what routing table information, since it is dynamically getting updated automatically, it is like what time is significantly saved, time consumption. It is significantly reduced because we don't have to go to each and every single router and we don't have to figure out that what is the next hop, what is the destination network which is not connected, and we don't have to define it manually to each and every single router to maintain connectivity. Because in static routing, always we need to know the destination, we need to know the destination subnet mask, we need to know the next hop IP address. If we don't know any of these things, then we cannot perform static routing. But in dynamic routing, we don't have to know all these destination informations. Okay, for example, from the perspective of gateway 1 doesn't need to know LAN number 3 and LAN number 4 because those networks which are not connected to it, gateway 1 is not even bothered about that. Okay, gateway 1 only cares about what networks it is connected to, and that is what exactly it is configured in dynamic routing. Router 1, LAN number 2 and 3 is like what connected. So it is only like what bothering about what networks these routers they are connected to. And they are not even like what bothered about this not connected networks. Okay. Because we are not talking about configuring not connected networks in dynamic routing. Always it is connected networks what we are configuring in dynamic routing. Always. Okay. So from the perspective of this distance vector routing protocol, this RIP is designed. Okay. On smaller networks, basically you have the support. Why we are saying smaller networks? Because maximum hop count we have 50. Okay. What is the hop count? Hop count is nothing but the number of routers, for example, okay, over here. When we are saying hop count is, for example, from here to here. This is considered as what? One,
Hop count.
okay, one hop count. Then from here to here, that is
Second hop.
another hop count, right? Another hop count. So if I say that from gateway 1 to this particular network, how many hop counts are there total? Two hop counts, right? Two hop counts. Likewise, okay, from one router to another router, that is your one hop count. From that router to another router, that is one hop count. So, like this, total how many hop counts you have in the RIP? Maximum 15
15.
hop count. 15 hop count means what? Total how many routers you can have? 16 routers, right?
15.
Total 16
16.
routers you have. So from here to here, from here to here, you are having 3 routers to hop count, right? So 16 routers will be having how many accounts? 15,
16.
right? This is what we are considering as hub count. Okay, so small network. Okay, 15, 16 routers. It is not a big network, it's small network only. So you have the support for it. Okay, beyond 16, you can see that the hub count of 16 is considered unreachable by you. Unreachable means RIP cannot perform routing beyond 16. Okay, hub counts. So hub count always matters. Okay, maximum to maximum 15 hub counts, not more than 15. Okay, if more than 15 is there, then RIP cannot do routing. Now it's an open standard routing protocol. Open standard means we are right now using all these routers, which is basically coming from what? Cisco, right? All these are Cisco routers, right?
Yes, sir.
All these are Cisco routers. But in the organization, you will be seeing that they are using mix of like what different companies routers. Like this one is Cisco router, this one is Juniper router, this is another company. This one maybe it is a TP-Link router, TP, or a Huawei router. There are different organizations out there. H Huawei. So different organizations routers like companies routers are there. Okay, in the same company. And what exactly you are having the support? The support means if you are configuring an IP in all these three routers, you can configure it. Okay, means every single company's routers they have the support to configure an IP. Okay, because these are different companies routers. Okay, and in all these organizations routers, if you want to configure a routing protocol, you must have like the support for it. Okay, not every single thing is supported to every single company's routers. This protocol, what we are using, is supported regardless of whichever company's router you are using. You can configure a IP. This is what you are getting the advantage. Okay, you don't have to use only Cisco routers to configure a IP. Even if you are using Cisco or a Juniper or any other company's router, you can configure an IP. This is what we are calling as open standard. It's an open standard protocol. Simply means that it has the support for configuration in multiple companies routers. Open standard. Okay. So open standard means regardless of whichever company's router you are using, always you have the support for it. Another thing is called Cisco proprietary. Cisco proprietary. Proprietary. Cisco proprietary simply means that only on Cisco routers only you can configure this protocol. Okay. Means if you are trying to configure a routing protocol in multiple companies router, but if it's a Cisco proprietary protocol, simply means that it is only configured only on Cisco routers, not in other devices. Okay. So Cisco proprietary means what? Only for Cisco devices you can configure it. It is not supported in other companies' routers. And open standard simply means that you can configure it in other companies' routers without worrying, okay, about any of these support related things. Because not every single protocol is supported on every single company's hardware. Okay. So proprietary always means that the manufacturer who has manufactured the product, only that manufacturer's products is supported by that protocol. Okay, not any other companies. And open standard simply means that any company's routers, okay, they have the support to configure this. Now, when you are using RIP, always it stands periodic routing update. Means dynamically the routing update is going on between routers. What this routing update simply means that all these routers, they will exchange something called routing 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 update packet. Okay, all these routers, they will be sharing routing update packet with each other. All these routers. Okay. So in the routing update packet, what exactly is going on is the routing table information. Okay. The routing table information. This is what exactly is there in the routing table. Okay. So all these routing table information of gateway 1, router 1, and gateway 2, it will be shared between these routers using this packet. Okay. And when this is shared, this is when exactly a router 1 comes to know about gateway 1's information. Router 1 comes to know about gateway 2's information. Gateway 2 comes to know about router 1's information. It is the information sharing, what exactly is going on by this particular packet. And it is about the routing table. Okay, this is the packet which is getting sent in a clear interval basis, means in every 30 seconds, this packet is getting sent by all these routers. They update their routing table in every 30 seconds. This is what we are having. This is the periodic routing update. How about you? So while sending update, it is the full routing table information is getting sent. Full routing table information means that, let's say that this router is maintaining its routing table. Okay, and it is about the two networks, let's say. So these are the two networks, LAN number 1 and LAN number 2. So two networks are there. So when it will be sending the routing update, it will include the two networks every single time, and it will be sending it to router 1 in every 30 seconds. These two networks informations are getting sent to router 1. Okay. Then router 1 will send its connected networks informations to gateway 1. Like that, everyone is will be sharing their connected networks. Okay. So by sharing their connected networks, other routers are coming to know about those networks which they don't know. Now the thing is, every single time it is sending the two networks information, it is kind of repetitive, the same thing, unnecessary information. Because first time, okay, first time you are sharing it, your two networks informations to router 1. So router 1 comes to know about your networks. But again, after 30 seconds, you are doing the same thing. Okay, again after 30 seconds, you are again sharing the same thing. The same informations are getting, like what are getting sent in a repetitive manner. This is what exactly is not good. Okay. While you send your routing table, you include everything, all the networks. For example, if there are 200 networks in your routing table, all the 200 networks you are sending, okay, to router 1, like what in every 30 seconds. This is something what exactly is coming as a disadvantage, because whenever any network is getting changed, let's say that this network is going down for some reason, then gateway 1 should update router 1 that this network is down. LAN number 1 is not working now. This is the update. It should be sent to router 1. So what exactly gateway 1 is doing, it is sending that update that LAN number 1 is down, but along with that update, it is also sending all these networks also to router 1. So when we are considering an update, okay, when we talk about update, this is not considered as an update. First of all these 200 networks already router 1 knows, because gateway 1 has already given that information to router 1. In the first 30 seconds itself, it has shared all the informations. So there is no point of sharing the same information again and again and again to router 1. When there is a change happened in the network to that LAN number 1, it is going down for some reason, then this update only should be sent to router 1, not all these networks which is already router 1 knows. This is what exactly is coming as a disadvantage because the grid doesn't understand these things. Okay, what exactly it is doing? It is sending the update, and along with the update, it is sending the full routing table. Okay, the entire routing table. So if the routing table contains only one network information, at the time also it is getting sent. If the routing table contains all the 100 networks information, at the time also it is getting sent. That is what we are saying, full routing. The hop count is it's counted as a metric. Okay, so metric is nothing but finding the best path. Okay. For example, let's say that we have this path right now from LAN number 1 to LAN number 4. This is the current path from here to here. This is what we are having the path. So in the upper path, the metric count, the metric for our IP is 2 to reach LAN number 4. From here to here, we have one hop count. From here to here, we have another hop count. So this is total metric hop count is 2. If we have another path, let's say that we have another router over here. We have another router over here. And we have another router over here. Okay. And in this manner, we are also connecting our routers like this. Then this is another path, what we are having to reach LAN number 4. So this is your lower path. And in the lower path, we are having one hop count, one hop count, one hop count, one hop count. So total we have 1, 2, 3, 4, 4 hop counts. So which path is the best? The upper path or the lower? Which path is the best?
Upper path.
Upper path, because over
Upper
here the
path.
metric is what? 2,
2,
and the lower path the metric is what? How much?
4.
4, right?
Yes.
1, 2, 3, 4. So obviously there is the best path. Okay, finding the best path, this is what exactly is determined by metric. And in terms of RIP, it is the hop count. This is the algorithm, what exactly is used to determine the best path. For any destination network, always algorithms are used. The name of the algorithm is Bellman-Ford algorithm in RIP. This algorithm is basically the concept of data structure. Okay, we're not basically discussing about data structure concept over here, but these algorithms are basically sets of formulas which helps like what the routers to determine that which particular path is the best path, because it's all about calculations. Okay, and it is covered in the data structure. So from the perspective of interview, we just have to know the algorithm name. Okay, uh, because that is totally algorithm is totally a data structure related subject. Okay, now RIP supports IP and IPX routing. Okay, these days everything we are doing it with IP. These days we are doing everything with IP, Internet Protocol. Our entire internet communication, what we are doing, it is done through IP. Okay, but IPX, it's a little bit old. Okay, means when we didn't have IP at the time we used IPX protocol. It stands for Internet Packet Exchange. Internet Packet Exchange. Okay, this is the old protocol before IP. It was used for doing communication. But when IP it came into existence, this is when exactly IPX is not being used that much these days, and everything we are doing, we are shifting totally from IPX to IP to do entire communication. So these days we are using IP. Everything is being done using IP protocol. This is the UDP port number 520, which RIP uses for establishing connections, for doing communications. It is unreliable. Okay, UDP is unreliable, but UDP is very fast. That is why we get the update also. We get to uh, like what update our routing table. These things happens very fast. Okay, because we're talking about dynamic. The dynamic routing always it erases the manual configuration related tasks. Okay, so obviously it is a little bit faster than static routing. Administrative distance of content. Administrative distance always helps routers to identify that which particular type of route is best. Okay, which route, which type of of route is best. Okay, which type of route? This administrative distance basically it tells the router that because we are having lots of type of routes like static route, we have connected route, we have RIP route, we have EIGRP route, we have OSPF route. But which type of route is best? This is what exactly the value decides that. Okay, always remember that lowest value always is preferred. Lowest value, and specifically we are talking about administrative distance. Okay, these administrative distance values are there. What are those values? We'll discuss. I will basically give you that table. You can see what type of route is having what administrative distance. And based on the value itself, router is deciding that whether they should be used a static route or RIP or HFP. Okay, based on this value. But RIP is having this value 120. Okay, administrative distance value is there. Two versions we have RIP version 1 and version 2. These are the differences. Version 1 is classful, version 2 is classless. Classful means if I'm using a class C network, okay, if I use a class C network address, it means I have to use /24. It is must. Class full. Class full means whatever class IP address you are using, okay, whatever class IP address you are using, you have to use that class subnet mask to do routing, okay. And classless means that you can use a class C network, but you don't have to use /24. Instead, you can use /25 slash any class subnet mask you can see, like /19. You can do subnetting and you can basically like what come up with the customized subnet mask. Okay, like doing subnetting, and we are coming up with different subnet mask. Classless means you don't have to depend on the class of IP to basically provide your subnet. Okay, subnet mask information. Okay, regardless of whichever class IP you are using, you can basically use whatever subnet mask you want. Okay, class full doesn't allow that. Full subnet mask means if it's a class C IP, then class C subnet mask should be used to do routing. If it's a class A IP, then class A IP should be used to perform routing in class full. And classless simply says that maybe it is a class B IP address, IP address, but we can use a class C subnet mask on it. Classless basically allows that. For example, 172.16.0.0/20. So this is a class B IP. Here I am using a class C subnet mask, and basically this includes that this will be network and this will be host. Okay, classless routing it is like that. Okay, no dependency on the classes to basically use a subnet mask, but in classful always it is dependent. Okay, so version 1 basically supports classful, version 2 is supporting classless. Version 1 doesn't support VLSM, so means you cannot do subnetting in VLSM like /25/29/19/21. This type of subnetting you cannot do, and you cannot do routing with it. RIP version 2 supports VLSI. Okay. So there are a couple of reasons why we are using RIP version 2 rather than version 1, because version 1 is old and doesn't support all these features what we use today. Apart from that, it uses broadcast address of 255. This is your IPv4 global broadcast address. What exactly is used for doing all the communications means every single update packet, what is getting sent from routers, they are getting sent using broadcast. But broadcast is not good from security purpose because everyone in the network is receiving it, and that is not considered good from the security's perspective. When we talk about reversion 2, then it uses multicast address of 224.0.0.9. So whenever it is sending RIP version 2 routers, they send like what are update packets, then they always use this address to send information because this is one to group. Okay, group one to group of repo of routers. Okay, group of repo routers, and this one is saying what one to all. Okay, so all routers, whether it is running RIP or whether it is running in, whether it is not running RIP, every single router is getting the information, which is not good. Okay, so security perspective, broadcast is not good, but multicast it is good. Routers running RIP version 1 RIP sends RIPv1 packet only, but can receive RIPv1 and v2 packet. Version 2 can send and receive RIPv2 packet only. Okay, what this point is saying to you is let's say that you are running RIP version 1 over here in this router, and you are running RIP v2 over here. So when this machine, okay, when gateway 1 will send something to here, this will send version 1 complete. Okay. It will send the version 1 update back. And when this machine will be sending it, it will send RIP v2 update. V2 update. Update. So this read version 1 can receive this version 2 update packet. Okay. Version 1 can receive it. They can understand what it exactly this IPv2 packet it looks like. Similarly, they can also receive the version 1 packet. If any router is also running the version 1, then version 1 packet also they can receive it. They can understand. Okay. So both versions update, this version 1 router can understand. But when it will be sending it, at the time it will send only version 1 update. This is the old version, what it sends. When RIP version 2 router receives it, okay, they don't understand any version 1 information, means they are not compatible with version 1. What exactly RIP2 routers understand is only version 2 packet only version 2. So if any version 2 router is sending them the packet, then they can understand it. But they don't understand anything which is coming from an RIPv1 router. So that is the reason it is not compatible. RIP version 2 is not compatible with RIPv1. And that is the reason we are having this particular point coming in difference. Coming to the four timers, we are having an update timer. What already we have discussed over here, you can see that periodic routing updates in every 30 seconds it is getting sent. So this is the default time. It is called update timer. There is a invalid timer available, which is basically 3 minutes. That is your 180 seconds. 180 seconds. Basically, whenever any network, let's say LAN number 1 is down. So this is your gateway. This is your gateway. gateway 1. So gateway 1 has lost connectivity to LAN number 1. Let's see. So what exactly it will do is it will wait. Okay, it will wait 3 minutes. 3 minutes it will wait. Okay, before it will declare this LAN number 1 as invalid, because earlier LAN 1 it was up. Earlier it was up, but right now it is down. So earlier it was valid information in the routing table. Right now it is not, like what, it is not up. So what exactly it is doing is, instead of immediately declaring it as invalid route, it is simply just waiting 3 minutes of time to declare it invalid. Okay. Means you are waiting 3 minutes before declaring this LAN number 1 as invalid in your routing table. Okay. Immediately you are not taking the decision to declare a particular route as invalid, but you are waiting around 3 minutes of time to declare a route as invalid. Okay. This is what is your invalid time. Because every single route what exactly is there in the router's routing table, this is what exactly you are having. It is this information. Okay. um, this is your valid information. Okay, so this is the valid information. What exactly is there? That is containing the best path, and this best path informations always it is there in the, that is your router's routing table, right? So if any network information is not working, this is when exactly you are having the 3 minutes timer, which your router is simply just waiting in order to declare that route as invalid. So that is your 3 minutes. Next, this is your hold down timer, where exactly you have the hold down. Hold down means what? Let's say that we have this your device this is your gateway 1, right? Gateway 1 is connected to your gateway 2. This is your router 1, correct? And this one is gateway 2, right?
Yes, sir.
So when let's say that this LAN 1 is down. Okay, so this is the router's routing table. And in the routing table, LAN 1 is not working, it is down. So this information, you basically, your gateway 1, it will hold within itself. It will never send this information in the update to router 1. Okay, because in every 30 seconds we are sending an update, but in the update packet we don't include those informations which is not valid. This is an invalid information. This information should not be sent to router 1. Okay, because gateway 1 is declaring that route as invalid, so there is no point of sending this invalid information to router 1. And that is the reason this 180 seconds time, that is second 3 minutes is there. Means for 3 minutes it will wait and it will simply hold these informations within itself only. Okay, it will hold down that information within itself, and it will never send any information regarding learn 1 to router. Okay, means only gateway 1 will know about that. Okay, and it will never send this invalid information to router 1, because there is no point of sending invalid information which is not correct. This is the 3 minutes hold down timer you are having, 180 seconds. And lastly, we are having the flash timer. Flash timer is like what, deleting that information exactly after 4 minutes. This is where exactly the information is getting deleted. Okay. So this is your invalid timer, that is your 180 seconds. And additional, this 60 seconds, this is the additional one. Additional. Additional 60 seconds we're waiting. Basically, we are waiting for receiving an update. Okay, means if the network is again coming up, okay, then this will be an update and we will update our routing table. Okay. But if we are not receiving any update, if the network still is down for 4 minutes, then there is no point of keeping that information in the routing table. We are simply just deleting it. So this is when the delete comes in. Okay, so you delete this LAN number one network information from your routing table. From your routing table. Okay, this is what we are having. The 4 times. So repetitive information. This is what exactly is going on. Okay, repetitive. You are basically sending the informations in a very repetitive manner. Okay, means if any informations are changed, if no update has happened, suppose you have not created any new networks or no network has gone down. Okay, these types of updates, if it is not happening at the time, also you were sending the information in 30 seconds. This is not considered good. Okay, because update is considered when something new is added into the network or something is changed. So this is what you are having. Configuration wise, this is the configuration what we are having. This is your interface configurations. The full configuration is there. This is your RIP configuration. We are running version 2 on every single routers. This is your connected network. So this is the gateway one. And we have our LAN number 1. This is LAN 1. And this is our LAN 2. Okay. This is the auto summary. Auto summary means summarizing information. Means let's say that you have two networks. You are summarizing in just one network, like 192.168.0.0. This is what means the first two octets you can see it is same, right? In both cases. This is what exactly we are making a summary. Okay. We don't want this type of summarization. That is why we deactivate the summary. Okay. This is when we disable it. So deactivating summarization always is done using not summary command and last exit. Okay, so very simple set of commands. You can see that the same set of commands are getting repeated over here also. Okay, these three commands are same. The only two commands which are basically changing over here, that is your network. And into the gateway 2 also we are having the LAN number 3 and 4 is coming over here, and everything is same. So configuration wise, there is no changes. Only the network part is changing because we are talking about connected networks. These three commands are same. Okay. So what exactly I want, Mukul,
Yes, sir.
is you will be doing this configuration. You will remove that static route, right? The static route configuration you have done, right?
Yes, sir.
You will delete that. So you will delete this configuration and you will write, you will just configure this RIP configuration right now. So simply just share your screen. Mukul is there. So that command you have given, right? Just open the gateway one. That just scroll up a little bit. The static routing configuration, what you have done, right?
Yes, sir.
Yes, just scroll up to that point. Over here, over here. You see this line, right? You see this line, right? Just copy, just copy the first line and add no in front of that to delete it. Do it from your global configuration mode. Both the routes needs to be deleted. You say no, no first, no, and paste it. Just paste it. Use the paste over here. No, I hope that it is not copied. First of all, copy it properly. Copy, select it first. Then do the right click, and copy. That's it. Now say no and paste that. Type no at the very first.
First type no, then paste it, and then first type no, paste.
No.
First
Then
type no. Or in the
I
same
type
in the same line you can. First type no,
no.
space, space, paste it, enter. Here now copy the second line and then again same.
One 103.0, right? No. That is not. Again, you have configured static routing. Okay. First of all, you have to delete this. Yes,
Press enter, press enter.
press enter. Delete this line again.
Again paste it. No, just to paste. No and paste, same thing.
Again, I have to type no and then write, then paste it again.
Paste it again and then change the value of 103 to 102.
Copy this line over here. Copy this first line and paste it. Simply just copy from no. Copy from entire line. Paste it. Yes. Enter. Check your routing tables. Exit. So it is the same way you do go on and do that on other routers. Do it fast.
center. अच्छा.
And
The second line. And last device.
should I exit, sir?
Yes, check the routing table. It's deleted, right? Move on to the next device. Don't do that like this. Always use your left and right arrow. Left and right arrow.
Yeah, okay. Done, sir.
Now, yes, Bhaskar is there.
Yes, sir.
That RIP configuration, you basically just tell him the configurations, what he needs to do on all these routers.
Okay, sir. 1 second, sir.
RIP configuration screenshot. Go to your gateway one and simply just start the configuration.
Type. First, go to configuration mode. Global configuration mode.
Config T.
Yeah.
Then
Now type router. All in capital letters. Router space RIP. This
RIP
is your
capital.
1 minute. Huh?
Gateway 1. This is gateway 1.
1 second. Yeah. 1 second. This is gateway 1, correct?
Yes.
Yeah. This we have done, correct?
Router.
Then RIP. Router RIP.
RIP.
Enter.
Enter.
Yes. Then version
Version
space 2.
2.
Enter.
Enter.
Then type network
Network.
Space
Space
192.168.
68.
100.0.
100.0.
Enter.
Enter.
Network
Network.
192.168. Hello, sir.
Tell me.
Hello.
Yes, sir.
101.0. 101.0.
Yes, sir, I know.
Enter.
Enter.
Sir,
No.
hello.
No.
Hello. No.
Yes.
Enter.
Space.
Space.
Space is auto hyphen without any space. Hyphen. No, not hyphen. Sorry.
Minus
Subject.
sign.
Minus sign. Summary. Enter. Then exit. Now go to router 1 configuration.
Config T.
Go to configuration mode. Global configuration mode.
Config T.
And type router. Same thing. Router space RIP. Enter.
Enter.
Yes. Version space 2.
Enter.
Yes. Then network 192.168.101.0. Enter.
Enter.
Yes. Network 192.168.102.0.
102.
Yeah,
102.
102.0. Enter.
Enter.
No space
Summary.
auto minus summary. Auto minus sign summary. Then enter exit. Then go to gateway 2. Same go to global configuration mode.
Config.
Router space RIP. Enter version space 2. Enter network 192.168.102.0.
102.0.
Yes.
Enter.
Enter network
Network.
192.168.103.0. Enter no space
Auto.
auto minus sign summary. Then same enter and then exit. Yes.
Again exit.
No, just close the window.
Okay, now send a ping from your PC0 to server. Any server, send a ping. It's coming, right? Reply is coming?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Again, send a ping?
Again sending the same ping, sir.
Yes. Working?
Yes, sir. Working.
Okay.
Yes, sir.
Receive 4 loss 0.
Yes.
100% success.
So you guys have got it right. How it's working? Connected
Yes.
networks. Okay, check the configuration out. You will see that only connected networks you are configuring. Okay, very simple, easy configuration. Anyways, you can close your share now. Okay, so that will be all, everyone. That is our next
So
concept.
any
What
steps or screenshot can we take?
Which one?
3 routers.
I have already given the configuration, right?
Yes, sir.
Okay, it's the same.
That is the same configuration.
Okay.
Okay. So this one we are having the next, everyone. Okay, this one we'll see in the next
Thank you.
sessions.
One
Just hold
question,
on,
sir.
hold on. Let me just take those screenshots. Okay, everyone. So I will see you guys in the next session. Okay. Bye.
Sir, one question. One question, sir.
Tell me.
Can router version 1 can read next router version 2, sir?
Yes.
Alright.
Yes. Yes. You can use. But the thing is, from the perspective of your version 2 device, it will be difficult to read version 1.
Okay.
Okay, because if this one is sending V1, then this one doesn't understand because only V2 is understood by your router.
Okay.
Okay. So your version 1 can read the information, but version 2 cannot read your version 1 information.
Okay.
Okay, so everyone, bye and take care. Okay.
Thank you, sir.
Thank you,
Okay,
sir.
bye.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.